Assalamu alaikum. In today's class, we're going to learn how to express expression of the form where you have two trigonometric functions, sine and cos, into a single trigonometric function, either with sine only or with cos only. In this, you've got two parameters. One is the value of r, which we have to learn how to find it out, and the other one is the value of alpha. Okay, let's start. If you want to convert it into the form where you have only sine, then you have to always keep the sine function first and then the cos function. And if you want to convert it to the form where you have cos in the answer, if in the single trigonometric function is cos, then you have to keep the term with cos first and the term with sine first. So you have to change the order. If in case you have to convert it into cos and you've got the sine function first, then you have to convert it in swap the function so that you have the cos function first and then the sine function. Okay, the value of r, once you've arranged it, then the value of r is the square root of the coefficient of the first function plus the coefficient of the second function, and the value of alpha is tan inverse of this coefficient of the second function divided by the first function. In this also, you don't put the negative signs. If any of these function the coefficient is negative, you just ignore it, and here also you ignore it and write down the positive, the value of the value, because you're finding out alpha, which is an acute angle, so it's always going to be the positive coefficient of both the functions. Okay, let's start with this question. Express each of the following in the form r sine theta plus alpha, where r is greater than 0 and theta is in radians. Okay, first of all, you need to change your um, you have to keep your calculator in the radians from, um, the angle unit should be radians. Okay, let's start. Okay, if I want to start with if I want to convert into sine, it's already in the form where sine theta is first. Okay, so it's going to be sine theta minus alpha. If you notice, with sine, whatever is the sign in between will come here. Okay, but in cos it will be reversed, so it's going to be, and this is written here. If it's this conversion with the sine into the sine form, whatever is the sign here is going to come here. But in case of cos, whatever the sign, you have to write down the opposite sign here in the bracket. Okay, so first of all, I'm going to find out the value of r. So r is going to be square root of 1 square plus 1 square. I'm just ignoring the negative sign of the 1. So it's going to be 1 plus 1, which is 2. So r is going to be root 2. Okay, alpha is always tan inverse of the second function divided by the first function. So alpha is going to be, we know tan inverse of 1 is pi by 4. So alpha is pi by 4. Just put it in the formula, r sine theta minus alpha. So r is root 2 sine theta minus pi by 4 is going to be the answer for this. Okay, the second one, okay, it's going to be r sine, let's assume that this is a positive here. Okay, it's going to be r sine theta plus alpha. R is going to be square root of 7 square plus root 2 square, which is going to be r equals to square root of 7 plus 2, which is 9, which is 3 actually. Square root of 9 is 3. So we already have the value of r. Now we can find out theta. Alpha is going to be tan inverse of the second function divided by the first function. So it's tan inverse of root 2 upon root 7, which is 0.491. Since the question does not say how many decimal places, if the question mentions that the value of alpha should be up to 2 decimal places, then you have to write it up to 2 decimal places. But since the question is silent about it, if the question is silent, if it is degrees, it should be up to 1 decimal place rounded off, and if it is in radians, it should be 3 significant figures. So it's 0.491. I'm writing 0.491. Plugging it into the function, I'm going to write it's going to be 3 sine alpha plus theta plus 0.491. This is the final answer. Now let's do question number 2, where to express it into the form r cos theta plus minus alpha, where theta is greater, r is greater than 0 and theta is in radians. Let's do the second question first, second part. Okay, so we know it's going to be, because because we have to convert it into the cost function, the cost function should be written first. So it's already in the form, into the form where the cost function is first. So we're going to write r cos theta plus alpha, because the sign here is negative, so it will be positive here. Let's find out the value of r. R is equals to 2 square root 2 square plus 2 square root 2 square. It's going to be 4 into 2, which is 8, plus 8, which is 16, root 16, which is a 4. The value of r is 4, and the value of theta is going to be tan inverse of 2 root 2 upon 2 root 2, which is actually 45 degrees in 45 in degrees. Tan inverse of 1 is 45 degrees. Okay, so it's going to be 4 cos theta plus 45 degrees. Okay, so this is the first one done. Now we're doing the second part. Let's take one more question from here. I'm taking this one. Let me take the D part. Okay, since the sine function is written here first, I will have to change the order so that the cos function comes first. Now it's going to be r cos theta minus alpha. In order to find out the value of r, it's going to be 12 square plus 5 square, which is 144, plus 25, which is 169. Square root of 169 is 13. Okay, and tan inverse of the second function divided by the first function once from here. So it's going to be tan inverse of 5 upon 12. Let me do it. Tan inverse of 5 upon 12, which is 22.6. So let's put it in the form r is 13 cos theta minus 22.6. This is the answer. Okay, let's move on to the next one. Question number 3. Express 5 cos theta minus 12 sin theta in the form r cos theta plus alpha. Okay, let's do the first part first. Okay, so it's going to be square root of 5 square plus 12 square, which is actually 13. So r is 13, and since cos function is already written first, so alpha is going to be tan inverse of 12 upon 5. 12 upon 5. Okay, which is 67.4. So 13 cos, you have a positive, is negative sign here, so it will be positive here. So it's going to be theta plus 67.4 degrees. This is the first part done. State the minimum and maximum value of this. Now see, these are the two functions. One is the cos function, the other one is sine function. So you can't use this. You can use this converted form to get the maximum or the minimum value. Now if you notice, if you remember in trigonometry, if you have a normal trigonometric function, for instance, if I say 2 cos x minus 1, and if I ask you to find out the maximum and minimum value of this graph, what you would do is this is the axis and this is the amplitude of the graph. Okay, so you would do axis plus amplitude and axis minus amplitude, whichever is the bigger number and whichever is the smaller number. The bigger number will become the maximum value and the smaller number would become the minimum value. But if you don't have anything here, for instance, the axis, in that case the axis is 0, so the minimum and maximum possible value would be the same method, axis plus amplitude, axis minus amplitude, so 2 and negative 2. Likewise, just like this scenario, you have the trigonometric function cos in this form. This is the amplitude and the axis is not written, meaning it's 0. So this is the axis and this is the amplitude. To get the maximum and the minimum value, axis plus amplitude is 13 and axis minus amplitude is negative 13. That means the maximum value of the function is 13 and the minimum value of the function is going to be negative 13. Okay, so I can write maximum value equals to 13 and the minimum value is negative 13. Then they're saying solve the question. Okay, now since you have a cos and a sine function, so it's difficult to solve. So what you do is you change the uh, polar form, which is this 13 cos theta plus 67.4 in place of 5 cos theta minus 12 sine theta, obviously, because we've already converted this into this form, equals to 4. Now how do we go about solving it? 13 is going to go in the denominator there. Cos of theta plus 67.4 equals to 4 upon 13. Okay, 4 divided by 13. Cos of theta plus 67.4 equals to 0.307. Now, since this is positive, that means the first and the fourth quadrant, because cos is positive in the first and the fourth quadrant. Let's find out the value. The basic angle is cos inverse of the answer, which is 70. Basic angle is 72.07 or 08. Okay, so the first answer is going to be 72.08, and the other answer will be in the, this is in the first quadrant. So for the fourth quadrant, I'll take 360 minus this answer, 360 minus the answer, which is 287.92. Now for theta, I'm going to subtract 67.4 from both these answers. So 72.08 minus 67.4 and 287.92 minus 67.4, which is, this one is, if you subtract it from 287.92, it's 220 point up to one decimal place, because it's an angle in degrees, so it will be 5, 220.5, and 72.08 minus 67.4, this is 4.68, so 4.7 in that case. These are the two answers. So we solve it a normal way, just like we solve a normal trigonometric equation and get the angles. We are doing the same thing in this question. The next question, question number 4. You have to convert express 3 sine theta minus root 3 cos theta into this form. Okay, let's do that first. And the angle unit should be in degrees right now. So I'm putting the angle unit into, sorry, radians. Angle unit should be in radians. Okay, so let's express it. R is going to be 3 square plus root 3 square into the square root. R is going to be 9 plus 3 square root of 12, which is actually, if you take the square root of 12, it's going to be 2. It's going to be 2 root 3. Okay. In order to get the value of alpha, I'm going to write tan inverse of root 3 upon 3, which is going to give me pi by 6. Okay, so alpha is pi by 6. Let's put it in the form r sine theta minus alpha. Because the sign here is negative, you have to put a negative sign only, and this is what they have told us. 2 root 3 sine theta minus pi by 6. This is done. Okay, state the minimum value of 3 sine theta minus 3 cos root 3 cos theta. Okay, so we've already converted into this form. Okay, so axis here is 0, so axis plus amplitude and axis minus amplitude. So the maximum value is this, and this is the minimum value. Okay, so I can write maximum value is 2 root 3 and minimum value equals to negative 2 root 3. Okay, and the smallest possible value of alpha for which they occur. Now if you want to find out the maximum value, because it's the graph of sine, so we know that the maximum value of the sine function, this is 360, this is 90, and this is 270. The maximum value occurs at 90 or pi by 2. Okay, so it's going to be okay, so the maximum value is 2 root 3. So I'm going to write 2 root 3 sine theta minus pi by 6 equals to 2 root 3. I want to find out Okay, what is the value of x at which the maximum value occurs? So when you divide it by 2 root 3, it's going to be sine of theta minus pi by 6 equals to 1. So sine inverse of 1 is pi by 2. So the maximum value occurs at pi by 2. So you have to solve this. Pi by 2 plus pi by 6. So it's 4 upon 6 pi, which is 2 upon 3 pi. Okay, and the minimum value occurs at negative 2 root 3. So you can just simply write 2 root 3 sine theta minus pi by 6 equals to negative 2 root 3. When you divide it on that side, it becomes sine theta minus pi by 6 equals to negative 1. And we know sine is negative 1 at negative 1 at 3 upon 2 pi. So you're going to write theta minus pi by 6 equals to 3 upon 2 pi and solve it. 3 upon 2 pi plus pi by 6. Okay, so it's going to be 10 upon 6, meaning 5 upon 3 pi. 5 upon 3 pi. Okay, so we can write that the maximum value is 2 upon root 3, which occurs at this point, and the minimum value is this, which occurs at this point. Now in the last part, they're saying solve the equation. Okay, let me just add a page here. They are saying in the last part, solve the equation 3 sine theta minus root 3 cos theta equals to root 3. Okay, we've already converted 3 sine theta minus root 3 cos theta into this form. So I'm just writing down the form here. It's this. Okay, so in place of this whole thing, I can write 2 root theta is root 3 sine of theta minus pi by 6 equals to root 3. You have to solve this. Now see, in order to solve this, I'm going to write sine theta minus pi by 6 equals to root 3 upon 2 root 3. So I'm going to get this. Root 3 and root 3 will cancel out. You're left with 1 upon 2. And now the basic angle sine inverse of half is a 30. Okay, so 30 in terms of pi is going to be pi by 6. So the alpha is pi by 6. And we have to find out the angle in the first and the second quadrant, because sine is positive and the value of sine is coming out to be positive, which is sine is positive in the first and the second quadrant. So if the basic angle is pi by 6, so theta is going to be theta minus pi by 6. One answer is pi by 6. And the second quadrant will be pi minus pi by 6, which is 155 pi by 5 pi upon 6. Okay, now in order to get the value of theta, I'm going to add pi by 6 to this and pi by 6 to this as well, which is going to give me 2 pi by 6, which is pi by 3. Okay, so it's pi by 3. And if I solve this, I will get 6 pi by 6, which is pi. These are the two answers for this part. Let's move on to the last question. Okay, so express 2 sine 2 theta plus 3 cos 2 theta in the form this. Okay, so r is going to be square root of 2 square plus 3 square, which is 4 plus 9, which is 13, square root of 13. Okay, and alpha is going to be tan inverse of 3 upon 2. Okay, the angle should be in degrees, so I'm changing into degrees now. Tan inverse of 1.5, which is coming out to be 56.3. Okay, so it's 56, alpha is 56.3. So I can write it as root 13 sine 2 theta, whatever is the angle mentioned here. Okay, you have to write it as it is, plus 56.3. This is the answer to the first part of the question. Now, in the second part, they're saying state the minimum and the maximum value of this and the smallest possible value of theta for which they occur. Okay, so we've already converted into this form, so we can use this form. Okay, so we know that um, the axis here is a 0. So what we can do is, for maximum value and the minimum value, I can do axis plus amplitude, axis plus amplitude, and axis minus amplitude. So this is the maximum value and this is the minimum value. And now you have to find out when does the maximum value happens. So you will have to write root 13 sine 2 theta plus 56.3 equals to root 13. Okay, so when you go to divide root 13 from this side, you will get sine of 2 theta plus 56.3 equals to 1. And we know the basic angle is going to be pi by 2 now, and pi by 2, because the maximum value of sine is at pi by 2 only. Okay, sine inverse of 1 is going to give us pi by 2. Pi by 2, in other words, in degrees, it should be 90 degrees. 90. So you're going to write 2 theta plus 56.3 equals to 90. So 2 theta equals to 90 minus 56.3. 90 minus 56.3, which is 33.7, divided by 2, which is 16.8. So theta is 16.8. Okay, so you can write, I'm doing the minimum value wala part here on this side. Okay, so root 13 sine of 2 theta plus 56.3 equals to negative 13. Okay, so it's going to give you 2 theta plus 56.3 equals to negative 1. So if you don't want to do this step, you know that the minimum value of the sine graph, if you have this observation and if you remember the graph of sine, it is 0 at 0, 1, it's 0 at 180 and 0 at 360. At 90 it has the maximum value, at 270 it has the minimum value. So the graph of sine is somewhat like this. So the minimum value always occurs at 270 degrees. So you can find out, we know that the basic angle is 270, so we'll write 2 theta plus 56.3 equals to 270. 2 theta equals to 270 minus 56.3. Theta is, I'm just solving this, 270 minus 56.3 divided by 2, so it's 106.8. Okay, so I can write the maximum value is at root 13, and it occurs at when theta is 16.8, and the minimum value is negative root 13, and it occurs when theta is 106.8. Solve the equation. 2 sine 2 theta plus 2 cos 2 theta equals to 1. So we have to do the last part now. This we can convert it, we've already converted into the polar form, so I'm writing down the polar form here. Root 13 sine 2 theta plus 56.3, okay, equals to 1. So you have to solve it. Sine of 2 theta plus 56.3 equals to 1 upon root 13, which is 0.277. Okay, sine inverse of the answer. Sine inverse of the answer is 16 point something. Okay, 16 point, and it's positive. You have to find it out in the first and the second quadrant. So the basic angle is coming out to be 16.1. So the value of 2 theta plus 56.3 is 16.1, and 180 minus 16.1, which is 163.9. Okay, now look at the range. Okay, if you look at this range here, the range, the domain for theta is 0 till 360, but we have to find out the angle for 2 theta plus 56.3. So 2 theta is going to be 0 till 720, and 2 theta plus 56.3 would be 56.3 up to 720 plus 56.3. That means the maximum you have to go is up till 776.3. Okay, so you have to accept all angles from 56.3 up to 776.3. So I will not accept this, but I have written it down here. Okay, so I'm just putting a line here. Okay, so the first quadrant and the second quadrant. Now if I keep on adding 360 to these until I reach 776.3, let's do that. 16.1 plus 360 is 376.1. 376.1 plus 360 is still within the range, which is 736.1. Now I'm going to do 163.9 plus 360, which is 523.9, plus 360 would go out of the range, so I'm not going to accept this. Now these are the four answers which I've got for 2 theta plus 56.3. So I have to subtract 56.3 from all of them and then divide by 2 and write down the answer. So the answer for theta will be, from each angle you will subtract 56.3 and then divide by 2. Okay, so the first I'm doing that. Okay, so 163.9 minus 56.3 divided by 2 is giving me 53.8. The first answer is 53.8. The second answer is 159.9. The third answer is 233.8, and the fourth answer is 339.9. All answers up to 1 decimal place because these are the answers of angles in degrees. Okay, this is the final answer. Thanks a lot. In the next video after this, we will be learning how to find out the maximum and minimum value function of the reciprocal functions, which is in the polar form. Thanks a lot for watching the video.